Imagine staring at the night sky, knowing that for the next 57 consecutive nights, thousands of tons of high explosives and incendiary bombs will rain down on your home. You are not a frontline soldier, but a factory worker, a clerk, or a mother in London. The year is 1940, and the German Luftwaffe is attempting to do what no military force had ever successfully done before. They are trying to bomb a major industrialized nation into total submission. This was the Blitz. It was an unprecedented campaign of terror from the air, designed to break the psychological spine of the British Empire and pave the way for a cross-channel invasion. But instead of shattering British morale, it forged a steel resolve that would ultimately help dismantle the Third Reich. Welcome back to the channel. We dissect the raw mechanics of warfare, stripping away the Hollywood myths to show you the cold, hard logistics, tactics, and technologies that actually decide the fate of nations. If you want to understand how wars are truly fought and won, hit that subscribe button and ring the bell so you never miss an analysis. Before we dig into the tactical weeds, let me ask you this. Drop a comment below and tell me how you think a modern American metropolis, with all our current infrastructure, would hold up to 2 straight months of unyielding, indiscriminate aerial bombardment. To understand why the Blitz happened, we have to look past the summer of 1940 and rewind to the muddy trenches of the First World War. By 1917, the stalemate on the Western Front had forced military thinkers to look to the sky for a way to bypass the meat grinder of the trenches. The Germans launched Gotha heavy bombers against London, causing panic and exposing a terrifying new reality. The English Channel was no longer an impenetrable moat. After that war, an Italian general named Giulio Douhet wrote a highly influential treatise, claiming that the bomber would always get through. He argued that future wars would be won not by armies clashing in the mud, but by massive fleets of bombers destroying a nation's industry and crushing civilian morale until the population begged their government to surrender. This theory infected the minds of military planners worldwide. In the United States, the Air Corps Tactical School at Maxwell Field adapted the doctrine of high altitude, daylight precision bombing, believing heavily armed bombers could defend themselves while surgically destroying industrial bottlenecks. The British Royal Air Force, or RAF, eventually leaned heavily into night area bombing, accepting that finding a specific factory in the dark was nearly impossible. So they would just flatten the whole industrial zone. But the German Luftwaffe evolved differently. They were built primarily as a tactical air force designed to provide flying artillery and close air support for the rapidly moving panzer divisions of the Blitzkrieg. They were a sledgehammer meant to smash frontline defences, not a strategic scalpel meant to dismantle an economy from 500 miles away. This fundamental mismatch between the tools the Luftwaffe had and the strategic mission they were given in the autumn of 1940 is the central tragedy of their campaign. By June of 1940, the geopolitical map of Europe had been radically redrawn. France, possessing one of the largest armies in the world, had collapsed in just 6 weeks. The British Expeditionary Force had barely escaped annihilation at Dunkirk, leaving behind nearly all their heavy equipment, tanks, and artillery on the beaches. Britain stood entirely alone. Adolf Hitler, expecting the British to sue for peace, was met instead with the defiant rhetoric of Prime Minister Winston Churchill. Frustrated, Hitler issued Directive No. 16 on July 16, 1940, ordering the preparation of Operation Sea Lion, the amphibious invasion of Great Britain. But there was a massive, lethal obstacle. The British Royal Navy was the most powerful fleet on the planet. If the German army tried to cross the English Channel in their makeshift fleet of river barges, the Royal Navy would turn the channel into a slaughterhouse. The only way to keep the British fleet at bay was to establish absolute air superiority over the landing zones. The Luftwaffe had to destroy the RAF. This initiated the Battle of Britain. Throughout July and August, the head of the Luftwaffe, Reichsmarschall Hermann Göring, threw his air fleets against British radar stations, airfields, and aircraft factories. It was a brutal, grinding war of attrition, but by late August a critical shift occurred. An accidental German bombing of London led to a retaliatory British raid on Berlin. Hitler was enraged. He ordered a complete change in strategy. Instead of focusing exclusively on destroying the RAF fighter command, the Luftwaffe was ordered to redirect its massive destructive power against London and other major British cities. Does changing your primary target, just when your enemy is on the ropes, ever actually work? History tells us it almost always backfires. Look at the American experience in Vietnam during Operation Rolling Thunder from 1965 to 1968. The United States dropped hundreds of thousands of tons of bombs on North Vietnam to break their will to fight and halt the logistical flow down the Ho Chi Minh Trail. Instead of breaking the North Vietnamese, the bombing hardened their resolve, unified the population, and forced them to adapt their logistics into an underground, highly resilient network. Similarly, if we look back at the American Civil War, when Union General William Tecumseh Sherman made his march to the sea, he deliberately targeted Southern infrastructure to break the Confederacy's will. But Sherman was doing this with an army on the ground, physically occupying the space and destroying the means of production by hand. You cannot occupy a city with a bomber. You can only smash it and hope the people inside give up. The Germans in 1940 were about to learn that bombing a proud population rarely breaks them. It usually just makes them angry. Let us break down the opposing forces, starting with the attackers. The Luftwaffe was divided into massive regional commands called Luftflotten. Luftflotte II, commanded by Field Marshal Albert Kesselring, operated out of the Low Countries and northern France. Luftflotte III, under Field Marshal Hugo Spell, was based in western France. Together, they commanded a formidable armada, but it was an armada built for the wrong war. The primary bomber of the German fleet was the Heinkel He 111. It was a twin-engine medium bomber, easily recognizable by its fully glazed, greenhouse-style nose. It could carry a payload of about 4,400 pounds of bombs. It had a cruising speed of around 230 miles per hour, which was decent for the mid-1930s when it was designed, but dangerously slow by 1940. More importantly, its defensive armament consisted of only a few 92mm machine guns. They were practically pea shooters against modern fighter aircraft. Then you had the Dornier Do-17, nicknamed the Flying Pencil because of its incredibly narrow fuselage. It was faster than the Heinkel, capable of outrunning some older fighters in a shallow dive, but it carried a much smaller bomb load, only about 2,200 pounds. The most modern bomber they fielded was the Junkers Ju-88, a highly versatile aircraft that could act as a level bomber, a dive bomber, and a night fighter. It was fast, rugged, and carried over 6,000 pounds of bombs, but there simply were not enough of them in service to carry the entire campaign. Notice what is missing from this lineup. The Germans did not have a heavy, four-engine strategic bomber like the American B-17 Flying Fortress or the British Avro Lancaster. They had toyed with the idea in the 1930s under a program called the Ural Bomber Project, but the German High Command cancelled it. They believed twin-engine bombers were more cost-effective and perfectly adequate for supporting ground troops in a European land war. This lack of heavy lift capacity meant that to deliver the same tonnage of bombs as a fleet of heavy bombers, the Luftwaffe had to fly many more sorties, exposing their crews to greater risk and burning through their airframes at an unsustainable rate. The primary munitions they dropped were the SC-250 and SC-500 general-purpose bombs, weighing roughly 550 and 1,100 pounds respectively. But the real terror weapon was the B-1E Electron incendiary bomb. These weighed just over 2 pounds each. A single bomber could carry hundreds of them in specialized canisters. When dropped, they scattered over a wide area, igniting upon impact and burning at over 4,500 degrees Fahrenheit. Water could not extinguish them easily. They were designed to lodge in the wooden attics of London row houses and start thousands of simultaneous fires, overwhelming the city's fire brigades. Because these medium bombers were slow and lightly armed, they required fighter escorts. This is where the German tactical doctrine completely fell apart. The primary German fighter was the Messerschmitt Bf-109E. Make no mistake, the Bf-109 was a masterpiece of aviation engineering. Powered by a fuel-injected Daimler-Benz inverted V12 engine, producing nearly 1,200 horsepower, it was fast, climbed like a rocket, and packed a lethal punch with two 20mm cannons and two machine guns. In a dogfight, it was arguably the best fighter in the world at that moment, but it had one fatal flaw. It was a point defense interceptor and a tactical air superiority fighter. It was not an escort fighter. The Bf-109 had an operational range of only about 400 miles. By the time a German fighter took off from the Pas-de-Calais in France, formed up with the slow-moving bombers, climbed to 20,000 feet, and crossed the English Channel, The pilot had barely enough fuel for 10 to 15 minutes of combat over London before a red warning light illuminated on his dash. That light meant he had to turn back immediately or ditch in the freezing waters of the Channel. The Germans tried to solve this range issue with the Messerschmitt Bf 110, a twin-engine heavy fighter known as a Zerstörer, or destroyer. It had the range to escort the bombers all the way to their targets and back. It carried a devastating armament of cannons and machine guns. But it was heavy, sluggish, and lacked the maneuverability to survive against agile single-engine interceptors. Instead of protecting the bombers, the Bf 110s often ended up needing Bf 109s to protect them. Now, let us look at the defenders. The Royal Air Force Fighter Command was led by Air Chief Marshal Hugh Dowding. Dowding was a brilliant, obstinate, and coldly logical commander. He understood that Britain could not win a war of attrition in the air if they fought on German terms. He needed a force multiplier. What he built was the Dowding system, the world's first fully integrated, ground-controlled air defense network. This was the absolute pinnacle of command and control in 1940. Along the southern and eastern coasts of Britain, the British erected a network of radar stations known as Chain Home. These massive steel and wooden masts broadcast radio waves out over the ocean. When those waves bounced off an incoming formation of German aircraft, the return signal was picked up by receiver towers. The Chain Home system operated on relatively low frequencies, between 20 and 30 MHz, which meant it was not highly precise by modern standards. But it could detect high-flying aircraft at ranges of up to 120 miles. This gave the British something absolutely priceless. It gave them time. Instead of flying constant, fuel-wasting combat air patrols over the coast and hoping to bump into the enemy, British fighters could sit on the ground, engines warm, pilots waiting in their dispersal huts. When the radar picked up a raid, the information was flashed by secure telephone lines to the filter room at Fighter Command Headquarters at Bentley Priory. There, women of the Women's Auxiliary Air Force placed wooden blocks on a massive map table, tracking the incoming raid's position, altitude, and estimated numbers. This information was then passed down to the group commanders. The most critical of these was 11 Group, commanded by Air Vice Marshal Keith Park, a brilliant tactician who controlled the airspace over London and the southeast of England. Park would look at the board, assess the threat, and scramble exactly the right number of fighter squadrons to intercept the bombers before they reached their targets. Once the German aircraft crossed the coastline, they were tracked by the Royal Observer Corps, a network of thousands of volunteers with binoculars and specialized plotting instruments who tracked the raids overland and fed the data back to the sector stations. It was a masterpiece of data processing and resource management. How many times in military history have we seen a numerically superior force dismantled by a smaller force with better intelligence? It happens constantly. Think about the Battle of Midway. The Imperial Japanese Navy brought an overwhelming armada to the Central Pacific, but American codebreakers had cracked the Japanese naval codes. Admiral Nimitz knew exactly where the Japanese carriers would be, allowing a smaller American force to ambush and destroy the heart of the Japanese fleet. Intelligence and command control are the ultimate force multipliers. The Dowding system was the 1940 equivalent of cracking the enemy's code in real time. To execute this interception, Fighter Command relied on two primary aircraft. The first was the Hawker Hurricane Mki. The Hurricane is often overshadowed in popular culture, but it was the gritty, dependable workhorse of the RAF. It accounted for roughly 60% of all German aircraft destroyed during the Battle of Britain. It was built using older construction techniques, featuring a steel and aluminum tube fuselage covered in doped fabric. This made it incredibly rugged. Cannon shells that would shatter a stressed skin fuselage often just punched clean holes through the fabric of a Hurricane. It was armed with 8 wing-mounted, 303 caliber Browning machine guns. While these rifle-caliber bullets lacked the explosive punch of German cannons, the sheer volume of fire, concentrated at a convergence point of about 250 yards, acted like a flying buzzsaw. The second aircraft was the legendary Supermarine Spitfire Mki. The Spitfire was an aerodynamic marvel. With its elliptical wings and stressed skin aluminum construction, it was faster than the Hurricane and highly maneuverable. It was powered by the magnificent Rolls-Royce Merlin V12 engine, a liquid-cooled powerhouse producing over 1,000 horsepower. This engine would later be adapted to turn the American P-51 Mustang into a war-winning escort fighter. The tactical doctrine of the RAF was simple but effective. The rugged Hurricanes were directed to attack the heavy, slow-moving bombers, while the faster Spitfires were sent higher up to engage and tie down the escorting Bf-109s. But wars are not just fought by pilots in the sky. They are fought by factory workers on the assembly line. The German High Command fundamentally underestimated British industrial capacity. The Luftwaffe intelligence chief, Joseph Schmid, produced reports that consistently exaggerated German production while severely underestimating British output. The Germans believed they were bleeding the RAF dry. They were wrong. Under the ruthless and highly effective leadership of Lord Beaverbrook, the British Minister of Aircraft Production, the British aviation industry was put on an absolute war footing. They streamlined production, standardized parts, and set up civilian repair organizations that could take a crashed Spitfire, salvage the engine and wings, and have a rebuilt aircraft back on the flight line in days. By the late summer of 1940, British factories were churning out single-engine fighters at a rate of nearly 500 a month, significantly outproducing the German aviation industry. The RAF was losing pilots faster than they were losing planes. To solve the pilot shortage, they pulled in volunteers from across the globe. Poles, Czechoslovaks, Canadians, Australians, New Zealanders, and even a handful of Americans who crossed the border into Canada to volunteer, formed the desperate, exhausted, but highly motivated shield of the British Isles. This was the strategic and tactical reality as the summer faded into autumn. The Luftwaffe had failed to destroy Fighter Command. Operation Sea Lion was becoming a logistical impossibility as the autumn weather approached, bringing rough seas and heavy fogs to the English Channel. Hermann Göring needed a victory. He needed to prove to Hitler that air power alone could force the British government to capitulate. The decision was made to shift the full weight of the German bomber fleets away from the battered RAF airfields and hurl them directly at the heart of the British Empire. London, a city of over 8 million people, a sprawling metropolis of docklands, factories, government buildings, and densely packed residential neighborhoods. The German command believed that if they could burn the docks, destroy the utilities, and inflict enough terror on the civilian population, the British government would collapse from within. They loaded their Heinkels and Dorniers with high-explosive bombs designed to shatter buildings and water mains, and thousands of those magnesium incendiary bombs designed to start uncontrollable fires. The intelligence was gathered. The target maps were drawn. The fuel tanks were topped off, and the bomber crews of Luftflotte 2 and 3 were briefed for a massive, coordinated assault. The date was set for September 7, 1940. The British radar operators, staring at their cathode ray tubes on the coast, were about to see a swarm of blips unlike anything they had ever witnessed. The air raid sirens of London were about to wail, signalling the beginning of a nightmare that would not end for 57 consecutive nights. The Blitz was about to begin, and the skies over the Thames estuary were about to turn completely black with German bombers. Late in the afternoon on Saturday, September 7, 1940, the radar screens at the chain home stations along the southern coast of England suddenly filled with a blinding mass of returns. It was not a handful of scattered raids. It was a solid wall of aircraft forming up over the French coast. Nearly 350 German bombers, heavily escorted by over 600 Messerschmitt fighters, were crossing the English Channel in a massive, stepped-up formation that stretched for miles across the sky. Up until this exact moment, Air Vice Marshal Keith Park and his controllers at 11 Group expected the Luftwaffe to continue their grinding assault on the Royal Air Force sector airfields. Park scrambled his fighter squadrons to defend those critical bases, but as the immense German armada crossed the coastline and roared inland, they did not dive on the airfields. They maintained their altitude and held a relentless, terrifying course straight up the Thames estuary. By the time Fighter Command realized, the true target was the heart of London itself. Many of the defending Spitfires and Hurricanes were out of position, desperately trying to climb and intercept a force that had already slipped past the primary defensive screen. The target was the London Docklands, the absolute vital logistical artery of the British Empire. To understand the sheer destruction of this specific attack, we have to examine the mechanics of German aerial bombardment. How exactly does a bomber crew, sitting at 15,000 feet, actually hit a target on the ground? The Luftwaffe relied heavily on the Lotfe 7 tachymetric bomb sight. Much like the highly classified American Norden bomb sight, the Lotfe 7 was an analog computer. The bombardier, lying prone in the glass nose of a Heinkel He 111, would input the aircraft's airspeed, altitude, and estimated wind drift. The sight would then calculate the exact release point. But there was a massive tactical vulnerability built into this system. To get an accurate drop, the bomber pilot had to fly straight and level, without taking any evasive action, for a minimum of 40 to 60 seconds during the final bomb run. Have you ever tried to drive a car perfectly straight while someone is throwing rocks at your windshield? Now imagine doing it while explosive artillery shells are detonating on all sides of your unarmored aircraft. This straight and level requirement made the bombers incredibly vulnerable to heavy anti-aircraft fire. The British ground defence relied heavily on the QF-3 7-inch anti-aircraft gun. This was a beast of a weapon, roughly equivalent to the American 90mm M1 anti-aircraft gun. The 7-inch gun fired a 28-pound high-explosive shell at a muzzle velocity of nearly 2,600 feet per second, capable of reaching altitudes over 32,000 feet. But in 1940, these shells did not have proximity fuses. They relied on mechanical time fuses set by the gunners before firing. The gun crew had to calculate the bomber's altitude, estimate the flight time of the shell, set the fuse, load, and fire, hoping the shell would detonate exactly when it intersected the enemy aircraft's flight path. The mathematical probability of actually hitting a maneuvering bomber was abysmally low. It took an average of 20,000 artillery shells fired to bring down a single German bomber. The primary function of this heavy flak was not necessarily to destroy the enemy, but to disrupt their bomb run, forcing the pilots to weave and break formation, which scattered their bombs wildly off target. But on the afternoon of September 7, the sheer volume of German aircraft overwhelmed the localized defences. At exactly 5 p.m., the first high-explosive bombs slammed into the Surrey commercial docks and the West India docks. The logic behind targeting the docks was sound military strategy. This was where the raw materials of the Empire arrived to feed the British war machine. But the docks were not just concrete piers. They were surrounded by hundreds of massive, multi-story brick warehouses packed to the rafters with highly combustible goods. There were warehouses holding millions of gallons of high-proof rum. There were buildings stuffed with raw sugar, thousands of tons of dry timber, rubber, and industrial paint. When the Luftwaffe dropped their SC-250 high-explosive bombs, the blasts shattered the municipal water mains buried beneath the streets. Then they dropped the incendiaries. Thousands of magnesium bombs crashed through the slate roofs of the warehouses, igniting instantly. With the water pressure completely gone, the local fire brigades were powerless. By 6 p.m., the various warehouse fires merged into a catastrophic, self-sustaining firestorm. If we look back at the Great Chicago Fire of 1871, or the devastating fires following the 1906 San Francisco earthquake, we see the terrifying physics of an urban firestorm. When a fire reaches a certain critical mass, it begins to create its own weather system. The intense heat, reaching over 2000 degrees Fahrenheit, causes massive updrafts of air. This violently sucks in oxygen from the surrounding area, creating hurricane-force winds at ground level that feed the flames and carry burning embers for miles. The London Docklands firestorm was so intense that the wooden blocks paving the streets spontaneously combusted. Firefighters from the auxiliary fire service, many of them civilian volunteers who had been accountants and shopkeepers just weeks prior, found themselves dragging heavy canvas hoses through boiling mud, their faces blistered by radiant heat that could melt the paint off a fire engine from 100 yards away. This inferno set the stage for the second phase of the attack, which revealed a glaring, fatal weakness in the British defence network. As the sun set and darkness enveloped the British Isles, the surviving daylight bombers turned back to France. But the relief was short-lived. At 8 p.m., the air raid sirens wailed again. A second wave of 250 German bombers was crossing the Channel under the cover of night. The Dowding system, which had proven so lethal during the day, was practically blind in the dark. The chain-home radar could tell controllers that bombers were coming, but once they were inland, the Royal Observer Corps could not see them to track their exact movements. Furthermore, standard daytime fighters like the Spitfire and Hurricane were virtually useless at night. A pilot flying in pitch blackness has almost no chance of visually spotting a bomber painted in matte black camouflage until he is close enough to collide with it. The British sent up night fighters, primarily Bristol Blenheims, but without onboard airborne radar. They were just stumbling around in the dark. How do you hit a target you cannot see? The Luftwaffe did not even need to see London that night. The glow from the burning Docklands was visible from the French coast, over 100 miles away. It acted as a massive glowing beacon guiding the night bombers directly to the drop zone. For the next 8 hours, the Luftwaffe pounded the burning city without facing any significant aerial opposition. They dropped over 300 tons of high explosives and an uncountable number of incendiaries. Entire residential neighbourhoods in the East End, populated by the working-class families who manned the docks and factories, were pulverized. When the all-clear finally sounded at dawn on September 8, over 400 Londoners were dead, and more than 1,600 were severely injured. But this was only night one. The heavy casualties suffered by the Luftwaffe during their daylight raids over the preceding months forced German high command to make a strategic pivot. Daylight bombing was simply too expensive in terms of lost air crews and aircraft. The Bf 109 escorts could not protect the bombers from the vicious swarms of RAF fighters. Therefore, Hitler and Göring ordered the campaign to shift almost exclusively to night bombing. They believed that the cover of darkness would provide immunity from British fighters, allowing them to systematically dismantle British cities night after night until the civilian population broke. This initiated a terrifying new phase of the war, a high-stakes game of electronic cat and mouse that would become known as the Battle of the Beams. If the bombers were flying at night, and they could not rely on massive fires to guide them every single time, how did they navigate to specific industrial targets in zero visibility? The Germans had developed a highly classified radio navigation system called Knickebein, which translates to crooked leg. This was an astonishing piece of technology for 1940. The Germans set up massive radio transmitters on the coast of occupied Europe. One transmitter would broadcast a narrow radio beam consisting of Morse code dots. A second transmitter, located miles away, would broadcast a beam of Morse code dashes. The bomber pilot would tune his receiver to these frequencies. If he heard dots, he knew he was drifting too far to the left. If he heard dashes, he was drifting too far to the right. But if he flew exactly down the center, the dots and dashes merged into a solid, continuous tone. This was the guide beam. A third transmitter would broadcast an intersecting beam across the guide beam. When the bomber flew down the solid tone and suddenly heard the intersecting signal, the bombardier knew he was exactly over the target, even if it was buried under heavy cloud cover, and he would release the payload. Think about how modern militaries rely on GPS for precision strikes. If you can jam or spoof the GPS signal, a smart bomb becomes a dumb piece of metal. The British, essentially, had to figure out how to spoof the German radio beams in 1940. A brilliant young British scientist named Dr. R.V. Jones figured out the Knickebein frequencies. The British rapidly deployed a network of countermeasures, codenamed aspirins. These were modified medical diathermy machines and radio transmitters that broadcast a fake dash signal into the German guide beam. When the German pilot tried to correct his course based on the fake signal, he would unknowingly fly miles off target. The British were literally bending the beams, causing German bombers to drop thousands of tons of high explosives into empty fields and the English Channel. This electronic warfare was a desperate, invisible battle fought in the ether, and it saved countless lives. Despite these brilliant countermeasures, the sheer volume of the nightly raids meant that bombs inevitably fell on the city. The psychological toll on the civilian population was immense. Imagine the sheer exhaustion of working a 10-hour shift in a munitions factory, only to hear the wail of the siren at dusk. Millions of Londoners retreated into the deep subterranean tunnels of the London Underground, sleeping on concrete platforms inches away from the electrified rails. Others huddled in Anderson shelters, which were curved sheets of corrugated, galvanized steel, buried half deep in their back gardens and covered with earth. These shelters could protect a family from shrapnel and falling debris. But a direct hit from a 500-pound bomb would obliterate them instantly. The nights were a symphony of terror. The heavy, unsynchronized drone of the German bomber engines, a sound the British called the synchronized throb, would vibrate in the chest. Then came the whistle of falling bombs, followed by the earth-shattering concussions that would blow out windows miles away. As October rolled into November, the Luftwaffe expanded their target list. They struck the industrial heartlands of Coventry, Birmingham, and Liverpool. The raid on Coventry on November 14, 1940 was so devastating that the Germans coined a new word, Coventrieren, meaning to completely annihilate a city. The Luftwaffe deployed a more advanced navigation system called X-Gerät, which the British had not yet fully jammed, allowing elite German Pathfinder squadrons to mark the factories of Coventry with incendiaries with terrifying precision. The resulting firestorm gutted the medieval city centre and severely damaged the aircraft engine factories. The British civilian casualty numbers were climbing into the tens of thousands. The emergency services were stretched to the absolute breaking point. The German strategy of night terror was operating with near impunity, as the British anti-aircraft guns and night fighters remained effectively blind. The situation was bleeding the British war effort white, and Prime Minister Churchill knew that if they could not find a way to shoot down the bombers in the pitch black of night, the industrial capacity of the island would eventually bleed out. The desperate need to shoot down German bombers in the pitch black of night triggered one of the most consequential technological leaps in military history. The British realized that ground-based radar, while brilliant for daytime early warning, was fundamentally inadequate for night interception. The chain-home radar could vector a night fighter into the general vicinity of a German bomber stream, but it could not guide the pilot to a specific visual target in the dark. The pilot needed his own eyes, and human eyes were useless at 20,000 feet in the dead of night. The solution was airborne interception radar, or AI, but early radar systems were massive. They required huge antennas and heavy power generators that could only be mounted on a battleship or a large plot of land. The physics of early radar relied on long wavelengths, which inherently meant large equipment. To fit a radar set inside a fighter aircraft, scientists had to figure out how to generate incredibly powerful radio waves at very short wavelengths, specifically in the microwave spectrum. This would allow for a small, dish-shaped antenna that could be mounted inside the nose of a plane. The breakthrough happened in a laboratory at the University of Birmingham, where two British physicists, John Randall and Harry Boot, invented the resonant cavity magnetron. This device was a masterstroke of engineering. It was a block of copper with precisely machined cylindrical cavities surrounding a central cathode. When a high-voltage pulse was applied in the presence of a strong magnetic field, it generated microwave radio signals at power levels thousands of times greater than anything previously achieved. It was small enough to hold in your hands, yet powerful enough to track an aircraft in the dark. Recognizing that they had the blueprint for a war-winning technology, but lacked the industrial capacity to mass-produce it, while under constant bombardment, the British government made a breathtaking strategic decision. In September 1940, a delegation known as the Tizard Mission secretly travelled across the Atlantic to the United States. They brought with them a black wooden box containing the cavity magnetron and handed it over to American scientists and military officials. American physicists at the newly formed MIT Radiation Laboratory were stunned. This single device accelerated American radar development by years. This exchange is widely considered the most valuable technology transfer in military history. It perfectly illustrates how the grand strategy of warfare is often decided not just by generals on a battlefield, but by physicists in a laboratory and industrialists on an assembly line. With the miniaturized radar now a reality, the Royal Air Force needed a platform to carry it. The standard Spitfires and Hurricanes were too small to carry the heavy radar equipment and the dedicated radar operator required to read the complex cathode ray tubes. Enter the Bristol Beaufighter. The Beaufighter was a brute of an aircraft. It was a twin-engine heavy fighter powered by two massive Bristol Hercules 14-cylinder radial engines, each producing over 1,500 horsepower. It was heavily armoured and monstrously armed. Mounted under the nose were four 20mm Hispano cannons, and housed in the wings were 6.303 caliber Browning machine guns. When a Beaufighter fired all its weapons simultaneously, the recoil actually slowed the aircraft down in mid-air. It was exactly the flying tank the British needed for the night war. Let us walk through the tactical mechanics of a night interception in the winter of 1940. A massive formation of Heinkel bombers crosses the English Channel. The coastal radar picks them up, and the information is fed to a ground control interception station. The ground controller, watching his own specialized radar screen, radios a Beaufighter patrolling at 15,000 feet. The controller gives the pilot a heading and an altitude, vectoring the heavy fighter into the bomber stream. Once the Beaufighter is within roughly 3 miles of the target, the ground controller hands the hunt over to the radar operator sitting in the back seat of the fighter. The operator stares at a small glowing green screen. He sees a blip. He calls out course corrections over the intercom, guiding the pilot. Port 10 degrees, up 500 feet, closing at 2 miles. The tension in the freezing, vibrating cockpit is absolute. At a range of about 1,000 yards, the pilot strains his eyes into the darkness. He is looking for the faint blue glow of the bomber's engine exhaust. Suddenly, a massive black silhouette blocks out the stars. The pilot aligns his glowing gun sight, waits until the bomber fills the reticle, and squeezes the firing button. 4 20mm high-explosive incendiary shells per second rip into the unarmored fuselage of the Heinkel. The bomber's fuel tanks detonate, turning the aircraft into a falling fireball. The Beaufighter violently yanks away to avoid the flying debris. This deadly cat-and-mouse game began to slowly turn the tide of the night war. Pilots like John Cunningham, nicknamed Cat's Eyes by the British press to hide the existence of airborne radar from the Germans, became national heroes as the kill tallies steadily climbed. But shooting down bombers was only half the battle. The true test of a nation under strategic bombardment is its logistical and economic resilience. The German High Command believed that by destroying factories and rail lines, they would paralyze the British war economy. They severely underestimated the adaptability of a highly industrialized society fighting for its survival. When a massive raid hit the Supermarine Aviation Factory in Southampton, temporarily halting the production of Spitfires, The British Ministry of Aircraft Production did not simply surrender. Under the ruthless direction of Lord Beaverbrook, they initiated a massive program of industrial dispersal. They broke down the manufacturing process into smaller components. Within weeks, Spitfire wings were being riveted together in requisitioned bus garages. Tail sections were being assembled in textile mills. Engine parts were machined in local auto repair shops. The finished components were then trucked to hidden, camouflaged airfields in the countryside for final assembly. The Germans could bomb the main factories to rubble, but they could not bomb 1,000 separate garages scattered across the English countryside. This level of logistical resilience has striking parallels in American military history. During the American Civil War, the Confederate Army frequently destroyed railroad bridges and tore up tracks to disrupt the supply lines of the Union Army. But the Union possessed the United States Military Railroad, commanded by the brilliant engineer Herman Haupt. Haupt organized highly trained construction corps that could rebuild a shattered bridge or relay miles of track in a matter of days, completely negating the Confederate tactical victories. When President Abraham Lincoln saw a massive bridge Haupt had rebuilt over Potomac Creek using nothing but raw timber and scavenged iron, he marveled that it was a structure made of nothing but cornstalks and bean poles. The British displayed the exact same logistical defiance during the Blitz. When the Luftwaffe dropped high explosives on the massive rail junctions of London, tearing up tracks and leaving craters 30 feet deep, the British railway repair crews moved in the moment the all-clear siren sounded. Working by floodlight and manual labour, they filled the craters, laid new wooden sleepers, and spiked down fresh steel rails. Often, a rail line that was completely obliterated at midnight was fully operational for the morning freight trains just 8 hours later. You cannot defeat a nation that repairs its infrastructure faster than you can destroy it. We also have to examine the profound psychological miscalculation made by Adolf Hitler and Hermann Göring. The entire premise of terror bombing is based on the assumption that civilian morale is fragile. The theory dictates that if you subject a population to enough death, fire, and destruction, they will panic, turn against their leaders, and demand a surrender. History has proven this theory fundamentally wrong time and time again. When you bomb a city, you do not break the population, you enrage them. The shared trauma of the Blitz forged an unbreakable solidarity among the British working and middle classes. It created what became known as the Blitz spirit. People adapted to the horror. They went to work in the morning, stepping over the smoking rubble of their neighbours' homes. They slept in damp underground train stations. They normalized the terror because the human mind is incredibly adept at normalizing extreme stress in order to survive. If we look at the United States Strategic Bombing Survey conducted after the Second World War, we see this exact same phenomenon in reverse. The United States 8th Air Force and the British Bomber Command dropped over 2.7 million tons of bombs on Germany. They reduced cities like Hamburg and Dresden to absolute ash. They leveled industrial centers. Yet, under the direction of Albert Speer, German armaments production actually peaked in late 1944. The civilian population did not rise up and overthrow Hitler because of the bombing. They just dug deeper into the rubble and kept working. Similarly, during the Vietnam War, the United States launched Operation Rolling Thunder, dropping a staggering amount of ordnance on North Vietnam. The goal was to break the will of the North Vietnamese leadership and population. It failed completely. It only hardened their resolve and unified the country against a common enemy. The historical lesson is absolute. Strategic air power can degrade an enemy's military capability. It can destroy their oil refineries and shatter their transportation networks. But air power alone cannot break the psychological will of a determined nation. To conquer a people, you must put boots on the ground and physically occupy their cities. The Luftwaffe could never do that because the Royal Navy controlled the sea, and the Royal Air Force still contested the sky. By the spring of 1941, the strategic landscape was shifting dramatically. The Luftwaffe was bleeding out. The continuous nightly raids were taking a severe toll on German aircrews and airframes. Operational accidents, terrible weather over the English Channel, and the increasingly lethal British night fighters were grinding down the German bomber fleets. Furthermore, Hitler's attention was wandering. The British were proving to be a stubborn, immovable object, and Hitler was inherently a man of grand, sweeping land offensives. His eyes turned eastward, toward the vast steppes of the Soviet Union. He issued Directive Number 21, the order for Operation Barbarossa, the largest land invasion in human history. To support this massive Eastern Front, the German army required absolute tactical air support. The bombers and fighters of Luftflotte 2 and Luftflotte 3 could not be wasted over London when they were needed to smash Soviet tank columns in Ukraine and Belarus. The climax of the Blitz occurred on the night of May 10, 1941. It was a night of unimaginable violence. The Luftwaffe launched over 500 bombers against London. They dropped over 700 tons of high explosives and thousands of incendiaries. The destruction was catastrophic. The House of Commons, the very heart of British democracy, was directly hit and destroyed. The roof of Westminster Hall caught fire. Over 1,400 civilians were killed in a single night. But this massive raid was not the beginning of a new offensive. It was a violent parting shot. Within weeks, the vast majority of the German bomber squadrons packed up their equipment, abandoned their airfields in France and the Low Countries, and transferred to the east. The skies over London finally fell quiet. The 57 consecutive nights of terror and the months of sporadic bombing that followed had come to an end. The human cost of the Blitz was staggering. Over 40,000 British civilians were killed, and more than 100,000 were severely injured. Over 1 million homes were destroyed or damaged. The architectural heritage of cities like London, Coventry, and Plymouth was scarred forever. Yet the campaign was a monumental strategic failure for the Third Reich. They failed to destroy the Royal Air Force. They failed to pave the way for an amphibious invasion. They failed to cripple the British war economy. And most importantly, they failed to break the spirit of the British people. The survival of Great Britain had profound, world-altering consequences. Because Britain did not fall, it remained an unsinkable aircraft carrier, anchored just off the coast of occupied Europe. When the United States fully entered the war after the Japanese attack on Pearl Harbor, Britain became the vital staging ground for the liberation of the continent. Without the airfields of East Anglia, the United States 8th Air Force could never have launched their daylight precision bombing campaign against German industry. Without the ports of southern England, the massive logistical build-up for Operation Overlord would have been impossible. There would have been no D-Day. There would have been no Allied march on Berlin from the West. The defiance of the British people during the dark winter of 1940 bought the free world the one commodity it desperately needed. It bought them time. It is a testament to the fact that wars are not just won by superior technology or heavier firepower. They are ultimately won by the sheer, unyielding endurance of the human spirit in the face of total annihilation. History is a relentless teacher, but its most important lessons are often written in the ashes of the cities that refused to burn away completely. Thank you for joining me in this deep dive into the mechanics and the madness of the Blitz. Before you go, I want to hear your tactical assessment. Which factor do you believe was the most critical in Britain surviving the Blitz? A. The technological leap of airborne radar and the integrated defense network. B. The unbreakable morale and logistical resilience of the civilian population. Or C. The fatal strategic errors and shifting goals of the German High Command. Drop your choice and your reasoning in the comments below. Hit that subscribe button, and I will see you on the next battlefield.